Hello, my name is Tyler, and I'm going to be presenting you today my Linux System Administration's course reflection. This is going to cover different topics that we covered in labs and lectures over the course of this class, and I hope you enjoy. So for section 1, I'm going to be covering software installation methods. This is going to be packet managers versus manual installations. Where this section we're going to be going over their processes and differences. So package managers are tools that automate the retrieval, installation, configuration, updating, and removal of software. They simplify software management by ensuring all necessary files and dependencies are installed. An example of this is the APT package manager used in the Ubuntu systems that we use for our labs. During the lab, I used the ATP to install SSH. This process was very straightforward and mainly requiring following standard package installation steps. Package managers are ideal for routine installations for standard software, providing a hassle-free approach that is particularly advantageous in environments where multiple systems need constant updates and maintenance. This image shows a command line using a package manager to update your file repositories to the latest version. Manual installations involve directly downloading and compiling the source code of a program. This method is essential for installing software versions not available through package managers or when specific configurations are needed. Manual installations require a deeper understanding of the system and are more error-prone. The process starts with downloading appropriate source code, followed by configuring build options, compiling the code, and manually handling the dependencies. This method offers greater control over the installation process. The flexibility to install specific software versions is a significant benefit. They offer a level of control over the system that package managers cannot, making them ideal for specialized software deployment scenarios. In summary, both package managers and manual installations have their place in Linux system management. Understanding when and how to use each method can significantly enhance system efficiency and customization, forming a fundamental component of Linux administration skills. Section 2 is about NetPlan utility, what it is, what it's about, and how we used it in our labs. So NetPlan is a network configuration tool for Linux systems that utilizes YAML-based configuration files to manage network settings. Its primary purpose is to abstract and streamline the configuration of network interfaces, making it easier to apply and manage network changes without dealing with lower-level networking commands. NetPlan comes pre-installed on many modern Ubuntu systems, integrating directly with our VM that we used and its networking setup. During the lab, I employed NetPlan to configure my virtual machines network interface by modifying the YAML files configuration to specify details like IP address, gateway, and DNS settings. NetPlan simplifies network management through an easy-to-understand YAML syntax, which is specifically beneficial for system administrators managing complex networks. Its declarative approach allows changes to be clearly stated and consistently applied across environments, making it an excellent tool for both small and large-scale network setups. The image shows what the YAML file for my VM looks like when we were doing the NetPlan lab. As you can see, it shows different network information in an easy-to-read way. In summary, NetPlan's simplicity and efficiency made it a suitable choice for modern Linux systems, particularly in environments where network settings are frequently modified or where multiple network interfaces must be managed concurrently. Section 3 dives into our focus on WireGuard and exploring its VPN capabilities. WireGuard is a modern VPN protocol that emphasizes speed, simplicity, and security. It uses state-of-the-art cryptography to provide secure connections to a remote network by encrypting its internet traffic, thereby protecting data from external threats. WireGuard can be installed on various operating systems using standard package managers. The installation process typically involves setting up WireGuard software, generating cryptographic key pairs, and configuring network settings. In Lab 7, I set up a WireGuard VPN server and successfully established a secure tunnel between my client and my server. The main task involved configuring network interfaces on both machines and ensuring secure key movement. The photo here shows the connection from the server to the client on my machine. WireGuard's primary benefits include its lightweight nature, fast performance, and enhanced security features. It is very well suited for environments where quick and secure remote access is necessary, such as telecommuting or connecting to cloud resources. For Section 4, I'm going to be covering over Docker. Docker is important for creating and sending containers, and we explored how to use it during this section of the course. Docker is a platform that automates the deployment of applications within lightweight and portable containers. Containers package an application along with its dependencies and allow libraries to run consistently across different computing environments. Docker is installed with a package manager or Docker's own installation script, which sets up the Docker engine on the host system. After installation, users can pull up and run container images from the Docker Hub or other registries. In Lab 8, I installed Docker and ran an official Apache Docker image. In the image that I put here on the slide, it shows an image that I downloaded from the Docker repository and showing that it came into my terminal. Docker offers benefits such as portability, efficiency in resource utilization, and ease of deployment. It is particularly advantageous for developing and deploying applications in a microservice architecture where containers can be independently managed and scaled. In Section 5, we'll delve into the two critical tools for log management: a syslog, a standard logging protocol for Unix systems, and Dozzle, a real-time log monitoring for Docker containers. So for the syslog utility, it is a standard logging protocol used in Unix and Unix-like operating systems. It facilitates centralized logging by collecting log messages from various services and applications, allowing system administrators to monitor system activities and troubleshoot issues effectively. Syslog typically comes pre-installed with most Unix-based systems. Configuration involves setting up a syslog to send or receive logs from other systems or applications within the network. In the lab, I configured the syslog utility to send logs from my client to a central syslog server. This setup was intended to centralize logging information, which aids in more effective monitoring and troubleshooting. Syslog is crucial for aggregating logs from multiple systems and applications, simplifying the diagnosis of issues across a networked environment. It is especially beneficial in large-scale or distributed systems where centralized logging is essential for effective system management. The Dozzle container is a web-based application that provides real-time logged monitoring from Docker containers. It features intuitive user interface that makes it easy to view. Search, and filter log data. It simplifies log analysis process for developers and system administrators. During the lab, I deployed a Dozzle container to visualize and manage logs from Docker containers in real time. It allowed me to monitor applications' behavior and troubleshoot directly from a web browser. Dozzle is particularly useful in environments where Docker containers are extensively used. Its ability to provide real-time, easy-to-access log information makes it ideal for scenarios where quick troubleshooting and real-time monitoring of containerized applications are necessary. In conclusion, Both the syslog utility and Dozzle container offer significant advantages for managing logs in IT operations. Syslog's ability to centralize logs enhances the oversight and troubleshooting capabilities across systems, while Dozzle's real-time monitoring and user-friendly interface improves the management of Docker container logs. These tools are instrumental in maintaining the stability and security of modern IT environments. In Section 6, I'm going over Uptime Kuma, which is a self-hosted monitoring tool designed to offer a robust alternative to commercial services like Uptime Robot. Uptime Kuma is designed to monitor servers, websites, and various applications, providing real-time status updates and alerts about downtimes or any operational disruptions. The tool includes features such as detailed dashboards, customizable monitoring intervals, and notification options. Uptime Kuma was installed as a Docker container, which involved pulling the image from a Docker repository and running it during the lab. During the lab, I configured Uptime Kuma to monitor several key components like our Apache web page, Apache container, Dozzle container, and Google's public DNS server. The image that I put on the slide is an example of the Kuma dashboard with its monitors for different applications. Uptime Kuma is highly beneficial for system administrators needing a centralized, reliable platform for service monitoring. It excels in environments where maintaining high availability is critical, such as web hosting or application development scenarios. The tool's open source nature allows for extensive customization, making it adaptable to specific monitoring needs and reducing operational costs. This section provides insight into the practical use of formatting and partitioning tools in our Unix system. So, file system formatting tools such as MKFS are used to prepare data storage devices for use, creating a file system. In this lab, we used mkfs.ext4 to format disks with the ext4 file system, which is a very robust and widely used used in Linux environments for its performance and journaling features. Partitioning tools like fdisk allow us to create and manage disk partitions, setting up structured storage space that can be individually managed. The tools used, including MKFS and fdisk, come pre-installed on Ubuntu servers. These tools are command line based, providing powerful options for managing disks and file systems directly from the terminal. In the lab, I formatted 2 disks using mkfs.ext4 and created a primary partition on each using fdisk, then created a RAID array with the new partitions. Using ext4 offers benefits such as journaling, which helps us protect us against data corruption and large file system support, making it ideal for servers with heavy data use. These tools are particularly useful in data centers, server environments, and for users requiring efficient management of large data volumes. Section 8 covers over what KVM is and how it runs. KVM is an open source virtualization technology built into Linux kernel that allows kernel to function as a hypervisor. It enables the running of multiple isolated virtual environments, referred to as the virtual machines or guests. Each virtual machine can run its own operating system independently of others, making KVM ideal for efficiently running Linux and Windows VMs under Linux. KVM installation on an Ubuntu server involves installing packages that provide KVM capabilities and tools necessary to manage virtualization. The initial step includes KVM and related tools on the installing KVM and related tools on the Ubuntu server. Then I configured and launched a TinyCore Linux VM using the virtual machine manager, which is what you see in the image from the lab that we did with KVM. KVM is particularly powerful for scenarios requiring dense virtualization, such as data centers and cloud hosting services, because it provides near native performance for VMs due to its direct access to underlying hardware through the Linux kernel. It's also beneficial in developmental environments for testing different operating systems or software versions in isolated settings without needing multiple physical machines. All right. And then for the conclusion, in conclusion, the comprehensive exploration of various technologies throughout the CIT 371 course modules has significantly enriched my understanding and skills in Linux system administration. From packet managers and manual software installations to advanced configurations using NetPlan, WireGuard, Docker, syslog, Dozzle, Uptime Kuma, file system formatting, partitioning tools, and KVM, each lab has served as critical learning steps towards mastering Linux, which is integral to my career path in cybersecurity and my future. And then here's some of my information. I have my email set up and my phone number, and you can contact me for any further information. Thank you so much for some of your time, and have a good rest of your day.